Hi guys, welcome to Geography 473-673, Open Sourced Environmental Computing. I'll be your instructor slash professor. My name is James Simpkins. You can just call me James, that's totally fine. And yeah, I'll be teaching you this course. This course is split up into two phases. The first phase is environmental computing with R, and that runs until October 1st. The second phase is Python based, and that will run from October 2nd to December 10th. And this entire course is really just about providing knowledge and coaching you guys through open source environmental computing, or just general programming knowledge in general. And what do I mean by open source is free. So we'll be covering R and Python. And these are two of the most popular languages in the world right now. I just checked before we got on. Python is currently the number one programming language in the world to know, and R is seventh, excuse me. So first and seventh out of hundreds of different programming languages. So not too shabby. And these languages alone can provide you with so much power. They can save you so much time and allow you to perform so many different routines or functions or analyses on any type of data imaginable. Anything you can do with a computer, you can do using R or Python. And you'll find both of these languages are being run around the world, not only at universities, not only at government agencies, but also for application development, websites. These languages are incredibly important. Knowing these languages will not only help with your own personal academic life and your academic goals and just things that you are pursuing in that regard, but they will also set you up for future success. And just knowing these two languages can really, really help you get a job. So a little bit of background about myself. I work for SEMA, which is the Center for Environmental Monitoring and Analysis. And we do a number of different things at the university. We have the densest weather station network in the world called Delaware Environmental Observing System. And so I work on making maps and managing those databases. I'm also involved with making a lot of the maps, radar maps and satellite imagery like so. I'm also in charge of the University of Delaware Satellite Receiving Station. Long story short, all of these tools that I'm using at the university really require a lot of programming knowledge. And actually, I'm self-taught in programming in R and Python, and I think being self-taught really lent me a unique perspective in the best way to learn it, because I spent a lot of time trying to figure things out, trying to code, and I definitely went the hard route. And I think that by myself going the hard route and figuring things out the hard way, it will hopefully make things easier for you. So the way that this course is going to be set up, everything is going to be right here for the R phase. I still need to figure out how to make a book for the Python phase, but this is what the book looks like for R. I've created everything you see here. So you can go through the chapters here on the left side, and we run through just getting started, how to download, and different aspects of R, kind of run through, share some videos that others have created on how to install what you need to install. These are very trusted things, and they are free. So do not hesitate to download these. Also, they take up a really small amount of space on your computer. You won't even notice it. Your hard drive won't even notice that these things are downloaded. These things are very small. I have definitions and rules over here, and this is really, I encourage you to run through these, but they will not make sense until you really start to go through the code yourself. But it's important to just know that this is here, and if you ever need to just, wonder what I mean when I use a certain name or nomenclature, you can come here for a definition and an example. Then we have fundamentals, and this is just kind of going through yourself, like running through this different code, what more examples about what different things mean, what's a vector, what's a matrix, what is coercion, and that kind of stuff. But all of that is really just getting set up, and then I also kind of have these base scripts here, and it just kind of runs through an R script and step by step, and just talks about like how we're doing that, and then at the very end we kind of collect all these scripts together. But the real meat of this course is done here in 6, 7, 8, 9. These are your tutorials. Each of these tutorials are designed to take a week. And by a week, I really just mean 2 class periods. The time it takes you to learn how to code and to stay up to date is really going to be fluid, and it's going to change. It is learning coding, learning programming, learning any kind of language is an exponential curve. What I mean by that is the progress might seem very slow at first, but the more you spend with it, the easier it will get, and you will really start flying as far as your ability to understand. And I hope that I will help fast track that ability with this book that I've written here. So each of these has a very specific tutorial to geospatial sciences. And so for the first one, we run through a scientific R script, just kind of a general example. And what we're doing here is we are really just trying to create a plot of something useful. And in this case, it's a data quality flag of sea surface temperatures. So it tells us what data is good and what data is bad of this entire image. Then we run through some time series analyses with DIOS weather station data. And we kind of take a look at mapping air temperature versus dew point on a couple of those days. Then we go back to oceanography for an example, kind of run through reprojecting and raster analysis, which is a pretty big feature of geospatial sciences. And we finish it off by having an assignment of tree cover percentage as a variable, and really trying to get after creating a plot of tree cover percentage. And then finally, the final week here is going to be reprojecting and writing rasters. And so I have just some quick tutorials on how to do that, and then you spend the majority of time in the assignment. Typically, under normal circumstances, what would happen is we would spend the majority of the first class. We're typically a Monday, Wednesday class, right? So we typically spend the majority of the first class on just kind of running through the last class's answer, the answer to the previous tutorial assignment, then running through some skills that we just want to have a little bit more practice with, and then the tutorial. And really, the second class period is really geared towards the assignment. And why is it like that? Because my entire philosophy is to not waste your time. Most of you are advanced degree students, and you have plenty of things on your plate. I'm just trying to fast track everything. And I think that this is a very hands-on course, because programming is a skill to be practiced, not a theory to be learned. We are not going to spend any time on theory in this class. If you want to spend time on theory, if you really are just loving programming and want to spend time on theory, I can direct you to other classes that you could take at the university. But this is a hands-on, straight to the point, straight to getting your hands dirty and playing with this data and coding yourself. This is that kind of class. So ideally, you may have to spend time outside of the, idealized 2.5 hours per week, 2.5 to 3 hours per week spending on this stuff. But it really is, that will be dictated by your ability to learn this programming. And like I said, my goal is to fast track this as much as possible to get you understanding as quickly and easily as possible. So everything that I think you'll need is right here. And even if you're on, the last week, you're not expected to know everything off the top of your head. You may need to look up, what is a certain aspect of this particular code? How do I find that? Where can I find the help function? You can just go back to your definitions and rules and find what you need. So that is a wrap. Just about wraps up the introduction to how this is going to work. The last thing that I will say is at the end of each tutorial, what we're going to do is we're going to have an assignment, and all I ask is that you follow the directions and you submit it to Canvas. Now, the one thing that I wanted to say about grading is that I am not a stickler. I am not here to throw you any curveballs. Programming is very logical and rational, and so is my grading style. I understand that most of you are advanced degree students, and your schedule is going to be fluid. I don't care if you turn things in after the week that we spent on that assignment. As long as everything is turned in before the end date of the semester, which is December 10th for us. So it's a little bit before finals. But as long as everything is turned in by then, you'll be good. That being said, I highly recommend that you just stick to the course, which is to do one tutorial per week. So, with that being said, that wraps up, that concludes this introduction video, and I look forward to having you all in this class and really hope that, this book that I've written here can really help you guys.